All right, so we are going to cover separation of variables in this video. That is differential equations. What are differential equations? Well, they're equations that have derivatives in it. So this is from 5.1, what we're covering right here, and we didn't quite cover this part. So we're finding a particular solution, and what they're asking you to do is look at this differential equation and verify this solution. So I guess what they're saying is that y equals this, and let's just look at this differential equation, right? X times y prime minus 3 times y equals 0. Well, we know that y prime is going to be, I don't know, 3cx squared. I'm going to say 3cx squared. We don't know what that constant is. It could be any number, but, and we also know that y is just cx cubed. So what's happening here is that you'll notice is that if you were to simplify this and simplify this, it would equal 0, in fact. So you're verifying that this is a solution. So what they're saying is the y that makes this equation work out with the y here, right, and the derivative here, and you take the derivative and the y and an x value, and it should all go ahead and equal 0 in the end. The y that is something x cubed, 2x cubed, 5x cubed, I don't really know. So the first thing I want to talk about is vocabulary. There's a lot of vocabulary here that stresses people out. You got particular solution, okay? You have differential equation. You have, let's see, the C obviously is just kind of throws people. You have initial condition, right? And then you have even something called, I think, general solution is another thing that they talk about. So this particular solution is sometimes called the exact solution. There's also something called a general solution. And a general solution is actually this, because it's not worked out for any particular point. It's just a generally what would work here, and it's not really solved out 100%. It's just the general solution. The exact solution, or the particular solution, is when you use the point to find the c. So it's something you've really done. At the end of the day, some of you are going to go into, or maybe at the end of your high school career, but I mean what I mean is, as an expression at the end of the day, some of you are going to go on to major in math or be engineers or something that's pretty math heavy. If that's you, you're going to have to take a class called differential equations. It's this, just an entire class on it. And the equations have y double primes in them, and they're bigger equations, and there's y prime squared, and there's all sorts of weird stuff going on. But this is basically the fundamentals. A differential equation is an equation with some derivative in it. And we want to know what the original y was. That's the big idea. Think about that. It's an equation with a derivative. We want to find the original y. So now let's talk about finding this particular solution. So we're going to go down here. We're going to erase a little bit of this stuff so that it doesn't like clutter everything up. So let's look at that. So don't let vocabulary stress you out too much. I'm going to get rid of that even. Okay. So we've done this. We're finding the particular solution to this equation. So what I'm going to write is x, and I'm going to write dy dx. That should be the first thing you want to do. And really what you want to do is, and I'm going to say this right here, okay, get, maybe we should make these steps, get dy dx alone. And then maybe step 2 should be separate the x's and the y's. And then step 3 would be antiderive, or integrate both sides. Step 4 would be plug in find c. Plug in, find c. Okay, so here you go. I gave you steps. You like that. Okay, so let's talk about what that means. Okay, so, well, I mean, we want to get this by itself. which makes sense because we're trying to find dy dx, and if we can get dy dx alone, then we can maybe move the dx over and get the dy to the left side, and so on and so forth. So I'm going to kind of just get there. We got x dy dx equals 3y, and I'm going to divide by the x so that I now have this equation. Okay, so take a second. You can pause the video, but that algebra should be pretty basic. I could cross multiply here. Or I could just, what could I do other than that? I mean, I could cross multiply, or I could just, what I think I'm going to do is I'm going to leave this as dy. I'm going to multiply the dx over. So that's what I have, okay? So let's look at what we want to get separated. Well, we've got a y here, and we've got a y here. So we want those together. Then we have an x here, and we have an x here. So those are kind of actually in a good spot. So I've got to get that y out of there. We need all the yellow on the left side. So I guess I'm going to write divide by y. I don't normally do this, of course, but this case, and I'll divide by y here. So that is going to cancel with that. Okay, let's take a second and see what we've got here. Let's go back to just normal black. dy over y equals 3 over x dx. Okay, that's pretty good. A couple things we could do. We can put the dx here if we wanted, but I don't really think it's necessary. So this is what we have. So if you think about it, we've got the dyx alone. We separated the x's and the y's. We now have to antiderive both sides. So antiderive both sides. Do that here. Okay, we're at a point where we need to understand that dy over y is the derivative over the original. That's going to be ln of y. It's going to be ln of the original. So ln of the absolute value of y equals. This is kind of the same thing. It's just that there's this 3 here that we could take out. And if you want, you have dx over x, right? It's the same thing. So this is actually 3 ln of the absolute value of x. And don't forget your plus c. So that's actually the general solution of the differential equation. It's not in a great form because y is not alone, but that is the general form. We're now at a point where we want to either get y alone or plug in our numbers. What I think I'm going to do is get y alone. So I'm going to go ahead and exponentiate both sides. Let's think about this for a second. I'm going to try something. I'm going to take a risk here. So I'm going to try, instead of getting y alone, I'm going to try and plug in my y equals 2 and my x equals -3. Okay? So what happens when I do that? Well, I have this equation, which is ln of the absolute value of 2 equals 3 ln of the absolute value of -3 plus c. Okay, so now what I see here is, let's see, how could I figure this out? I could just solve for c at this point, and it would be ln of 2 minus 3 ln of 3, I believe, and that should equal c. We'll verify this a little bit later. Take a second, don't dwell on this for a second, because this absolute value thing is really going to be annoying, tricky, so I'm going to take a moment and I'm just going to put a question mark over this, and we'll see. What I'm going to do is I'm going to solve for y now, because I know I've done that earlier and it's worked out, so I want to get y alone. So I'm going to exponentiate both sides. So this is e2 and this is e2. So if you want to put a caret there or something, I don't know. But it's e to that power. So e to the ln of y is just the absolute value of y equals, this can be confusing, but you really don't want this 3 here. You really want this 3 here. So you kind of want that. So now what you have is, what do you have? You have e to the ln, so I guess you have e to the ln of the absolute value of x, that's cubed, plus c, which equals, by the way, this equals, by the way, e to the ln of x cubed times e to the c. Because it's like addition of exponents, just that rule reversed. And e to the c is just this is just a constant. So because e to the c is just a constant, we're not going to write e to the c, we're going to write ce. It's multiplied by e to the c, and e to the c is just some constant, so we're just going to write c instead. So we're not going to overcomplicate our lives. All right, well, now we're going to have to figure out what's going on here. So we have the absolute value of y equals c, and then the e cancels the ln, and you have, I guess, the absolute value of x cubed. Right? So let's figure out what our y and our x are. Our y and our x that they gave us were 2 and negative 3. So this is 2 equals c, and then this is negative 3, but it's absolute valued. So that's just 3 cubed. So I wind up with 2 equals c times 27, I believe, and I get 2 over 27 equals c. So that's where I'm at. So let's see how that is. Is that a good thing? Is that a bad thing? I'm not sure. So give me a second to look that over. Okay, so here's where things get kind of weird. Right about here, right, we see this. And we know that the y, in this case, is positive. So if we're just analyzing signs, we have positive equals, right? And then we have our c, which we don't know what that is. And then we have our x cubed, okay? And the problem is if our c comes out, let's see, if our c comes out positive, Okay, so really, here's what we're going to do. Okay, I'm going to take it another direction. So you can see, these are hard problems. We got 2 over 27 equals c, right? And we can see our equation, it's got these absolute values in it. And really, when you have absolute values, you need to take, like, let's say you have absolute value of x equals 3. You need to break it into x equals 3, x equals negative 3. And if you have 2 absolute values, you need to break that into really 2 cases and then 2 more cases. So there's actually 4 cases here. I don't want to get into that right now. I just want to take this 2 over 27, my c, and see if it makes sense. Do I have my sign right? That's really my only concern. So if I take 2 over 27, right, and I put it into this, right here, y equals 2 over 27, right, and then I take my x value and I cube it. Well, let's look at our x and our y values. Well, they are in purple. So our x value was negative 3, and our y value was positive 2. So if that's the case, let's see if this is a good thing or a bad thing. Well, the problem is that you're going to have now a positive equaling, right, a positive times a negative, and that's not going to work. So our c must have been negative. We could have set up these 4 cases to get there. I think this problem was intended to not be so long. This, like, the problem that they wrote, their intention was for you to use this and just get the particular solution. But we kind of went all out and did it all. And hopefully I haven't confused you too much. My apologies for that. But I'm going to continue with another video, and we'll do a more straightforward example. We'll get those absolute values straightened out as time goes on through the course. So not the best, but at least we got to the answer. So we know the c is actually going to have to be, unfortunately, negative, because if it's not negative, we're not going to get a positive y, a positive 2y over here, right here. So negative times a negative is what we need. So this is actually a negative. Okay. Continue on to the next video, please.